All right, number 19. I gotta figure out what I do with my pen here. The graph represents the XY coordinates starting positions of 4 players on a soccer team. Diana is equidistant from James, Juana, and Ben. Okay, so they don't have this line in here, but I'm going to draw it in there. Juana is standing directly behind Diana. What are Juana's coordinates? Okay, so I suppose if we knew this distance, we could just apply that distance here and then, figure it out. Obviously, the x coordinate here is still going to be 1 because she's right behind her, which is weird because it looks, I would call that in front of, but whatever. Okay, so the distance of this line, when in doubt, Pythagorean theorem. Okay, so how far are we going horizontally here? Well, we're going from 1 to 2, which is a little weird, a little deceptive the way this is drawn. So that distance horizontally is 1 there. What is the distance vertically that we cover? Well, we're going from 2 to 5. So from 2 to 5 would be a distance of 3. So I would say 3 squared plus 1 squared equals c squared. I'm going to call this c here. So 9 plus 1, 10 is c squared. So c is radical 10. So the distance between Diana and Ben, Diana and Juana, and Diana and James, these are all square root of 10. So this distance here will be radical 10. So the y coordinate here for Juana will be whatever Diana was plus radical 10. So I'm going to call that 2 plus radical 10. Be really careful. Don't say that Juana's coordinate is radical 10. That's the distance here. Okay, Diana's already at 1, 2, right? So what that means is that the origin is probably like right here. And Juana is going to be at a y distance of 2 plus radical 10. So that would be answer choice A there. All right. 20, Matt makes 2 promises. He says, if I get a job, I'll get a new pair of jeans. If I get a new pair of jeans, I'll give away my old pair of jeans. Assume Matt keeps his promises and then he does not give away his old pair of jeans. What can be concluded? Well, if I get a job, I'll get a new pair of jeans. If I get a new pair of jeans, I'll give away my old pair. Matt did not give away his old pair. So let's use the contrapositive here. You ready? So the contrapositive says, if not Q, then not P. So we can say if 2 is true, then its contrapositive is also true. So in other words, we could say if I don't give away my old pair of jeans, then I did not get a new pair of jeans. Okay? If I did not get a new pair of jeans, we're going to do it again. If I did not get a new pair of jeans, then I did not get a job. Okay? So he does not get a job and no, B doesn't make sense. He gets a job, nope. D, he does not get a job and does not get a new pair of pants. Yeah, this would be the logical conclusion of that. Okay, that's that one. My battery may die at any moment here, so we'll see. All right, AC is perpendicular to GE. GD is perpendicular to BF. GH bisects EGD. The measure of BGC is 36. Man, what is the measure of EGH? Okay, so this is what we're going for here. This one right here. And that's what we want to know. Okay, very good. AC is perpendicular to GE. That means this is 90 degrees here. Also, this is 90 degrees. That may be helpful later. GD is perpendicular to BF. So, oh man, that means that this angle is 90 degrees. And also this angle here is 90 degrees. Kind of hard to visualize all these. GH bisects EGD. GH bisects. Oh, okay. So that means that this angle, the one that we're trying to find, is also congruent to this one right here. Right there. All right, and then BGC, this will probably be the most helpful information. BGC is 36 degrees right here. Okay, and we're trying to find this blue one. All right, so I'm just going to start writing some things down that I know. If this is 36, then we've got a vertical angle here, so this must also be 36 right here. If this is 36, then right here, this. All right, sorry about that. I got cut off there. So I was saying if this angle right here is 36 degrees, then the orange angle and 36 together must make 90. So this would be 54 right here. Okay. So if this is 54, then bear with me, I know this is getting a little tricky. This right here, this purple angle, which is kind of hard to tell apart from the blue, but this purple angle here is 90, right? Because we know that GE is perpendicular to AC. That was given here. So altogether, this is 90. So if this is 90 and this is 54 right here, then that means that the blue angles right here together, oh, I can't double mark that, I'll triple mark that. The green part right here plus 54, right? So the green plus the 54 must be 90. So the green triple angle I marked there must be 36, okay? So, and since these two angles are congruent because GH is a bisector of the angle here, then if they're 36 together, they must each be 18. They want to know what EGH was, so yeah, we'll say 18 on that one. All right, so that's 21. 22, the formula for finding the area of a triangle is 1/2 base times height, where b is the length of the base and h is the height. What is the area in square units of this triangle? Okay, well, we're just gonna have to figure out the base and the height. So the base goes from 4 to 10 sideways. So that'll be a distance of 6. Then the height goes from 12, right? So this is 12 up here down to 2, so this is 10. So I would say the area here is half of the base times the height. So half of 60 must be 30. All right, 23. Point D is located on AC. If the measure of angle ADB is 116, put that in, and point E is in the interior of angle BDC, so E is somewhere in the interior of this angle. So E is living, you know, somewhere over here, right? Like E could be here, it 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 could be here. Anything that's inside this angle right here. Which range represents the possible values for the measure of angle EDC? So EDC. Well, if E was like right on the edge here, so what I want to do when we talk about ranges is think about the most extreme endpoints, right? So E could be, E could be right in the middle here. But what's going to be helpful is thinking like, what if E was like right on the edge here? So E was like right here. Basically, the angle here would be essentially 0, right? We could get it to be, we can't get it to actually be 0 because then we wouldn't have an angle. But, just a little more than 0 we could get, right? So, like 0.00001 or something, right? So the measure of angle EDC would have to be greater than 0, right? And all of these answer choices have that marked, right? So it's got to be greater than 0, right? So the measure of angle EDC has got to be greater than 0. What is the largest that it could be? Well, if we go to the other extreme and we put E, we could put E in the middle, but what if we put E like right here, okay? Well, this angle right here is supplementary with 116. So 64, this is 64. So this angle could get all the way up to 64, but it couldn't actually be 64 because then E would not be in the interior, right? E has to be inside. So E can't be on this line right here. It's got to be slightly below it. So I would say that the measure of angle EDC has to be greater than 0, but slightly less than 64. All right, if this pattern continues, what would be the next figure in the pattern? I always love these. You always see these in like little puzzle game things or the newspaper. All right, so we got a triangle. It looks like every step we're flipping the triangle like this, right? So it looks like we're also losing a dot and we're gaining a line. So if we flip the triangle, lose a dot, gain a line, flip the triangle, lose a dot, gain a line. If we flip the triangle, lose a dot, and gain a line, so we'll have one dot left, and then we'll have 3 lines here, which it looks like is answer choice C. All right, 25. Which statement is logically equivalent to if a kitten is tricolor, then it is female? Let's just go through each of the choices here. If a kitten's female, then it's tricolor. That would be the converse, okay? The converse is not always necessarily equivalent to the original statement, so it's not A. If a kitten is not female, then it is not tricolor, okay? So if a kitten is tricolor, then it is female. This would be the contrapositive of 25. So yes, so B would be our selection here. If a kitten's not tricolor, then it's not female. That would be the inverse of the original statement, which isn't necessarily logically equivalent. And then choice D, if a kitten is tricolor, it's not female. Well, that's just dumb, right? That's saying the opposite of what this is saying. So, all right, that was B. All right, 26. Given this proof, what is the missing step? All right, AD is congruent to DC. I'm gonna mark those. Angle A is congruent to angle C. Okay. I'm gonna mark that. And we're trying to prove that these two triangles are congruent. So if we were going to prove this, I'm not even going to look at the graph here for a second. I'm going to cover this up. If I was going to try to prove this, I ask myself first, what would I do? Well, I would say that this was given and this was given, and then I would say, look, isn't this congruent to itself? Okay, so that would give us ASS, but oh, ASS doesn't work, so let's not do that. I mean, this is still congruent to itself, but that's not helpful. So now, well, that's weird. Oh, I see what we're going to do. If you got a triangle, remember, let's forget BD exists for a second. If you got a triangle and 2 angles are congruent in that triangle, that means the sides across from them are congruent. Okay, and I should double mark those, I'll triple mark those. So, okay, cool, so that's congruent to that. Okay, so now the 3 things we want are side, angle, side. Side, angle, side. Okay, so I would say what? That AB is congruent to BC. And that's because of the, basically the triangle isosceles theorem. BD, nope, that doesn't work because that would make ASS. Can't have that. Angle ADB is congruent to angle CDB. Perpendiculars form congruent right angles. Well, I mean, if we knew that these were perpendicular, I would say sure, but we don't know that those are perpendicular. If 2 pairs of angles are congruent, the 3rd pair of angles are congruent. Well, that'd be fine if we knew that 2 pairs were congruent, but all we know is that 1 pair of angles is congruent. BC is congruent to BA, the sides opposite congruent angles of a triangle are congruent. Yeah, so this one would be D right here.